What we're going to work on is we're going to expand what we did yesterday involving scientific notation, and we're going to tack onto that, and we're going to work with engineering and metric notation today. And they're just natural extensions of scientific notation. We've got a couple of things that we want to accomplish here. The first one is we want to be able to write numbers just like yesterday we converted numbers into and out of scientific form. Today we wanted to do the same thing, but we're going to work with engineering form. We want to interpret the meaning of some of the commonly used metric prefixes, which is really just an extension of engineering form. And we want to be able to determine the best prefix to use when you're writing values in metric notation. Now the metric prefixes are, the world is gradually switching to metric, and every technical field is becoming more and more exposed to the metric prefixes. We're going to start out with engineering notation. That's what we want to begin with. Engineering notation is almost exactly the same as scientific notation. There's two minor differences. The first difference is that our coefficient is no longer restricted to be between 1 and 10 anymore. Now it's allowed to be between 1 and 1,000. Scientific notation, as you did with your homework, the coefficient always has to be greater than 1 but less than 10. And now we've opened that window up so it can be between 1 and 1,000. But the exponent on 10 is going to be slightly more restrictive. Now it can't be just any old integer. Now it has to be an integer multiple of 3. So let's take a look at an example of a number here in engineering notation. 613.27 times 10 to the 6th. It's in engineering notation because that 613.27 is between 1 and 1,000, and 6 is an integer multiple of 3. And so it definitely is in engineering notation. Now here's two examples of numbers that are not in engineering notation. Excuse me, I said that wrong. This one is in engineering notation, right? Between 1 and 1,000. The power of 10 is 15. Excuse me, negative 15, but that's okay. Those two are not written in engineering notation. 83.2 times 10 to the 5th because 5 is not an allowed exponent. It's not a multiple of 3. 8,520 times 10 to the 9th? Too big. The coefficient is too big. Now they could both be changed or modified so that they are in engineering notation, but they're not the way they sit. So let's do a few examples. Let's write the number 494,200,000 in engineering notation. So let's begin by moving that decimal place. It starts out here at the end of the number. We can move it basically in groups of 3. We can't move it one space at a time. We can only move it 3 spaces at a time now. So we can move it 1, 2, 3, 4, 5, 6. If we stop right there, will our coefficient be acceptable? It will. It'll be 494.2. So we're going to move it 6 places. That, by moving it in groups of 3, that ensures your power of 10 is going to be acceptable, and then you just find the spot that gets your coefficient between 1 and 1,000. That turns out to be 494.2 times 10 to the 3rd. That's all there is to it. I'm sorry, 6. Good. Thanks. 494.2 to the 6th power. Let's try writing 0.00000000593 in engineering notation. Well, before we do anything, is our power of 10 going to be positive or negative? Negative. We're dealing with a very small number. That means a negative power of 10. So we can move it in groups of 3. We can move it 1, 2, 3, 4, 5, 6. We're going to have to move it 9 times to get an acceptable coefficient. This will become 59.3 times 10 to the, we moved it 9 spots, and it's a small number, negative 59.3 times 10 to the negative 9th power. That number is in engineering notation. Well, it's not very difficult at all if it is, we saw in the last 2 examples, if you're just starting out with a number in decimal notation. It's just like yesterday. You need to be a little bit more careful if you're going from scientific to engineering. Suppose we want to write 6.83 times 10 to the 7th using engineering notation. Now note that it's not right now. Now you have 2 choices. First of all, wouldn't you agree that that power of 10 is either going to have to be 6 or 9? We're going to have to go to one of the 2 because those are the 2 nearest multiples of 3. But only one or the other will leave the coefficient between 1 and 1,000. What do you think? What should we do? 68.3 times 10 to the 6, would that work? It would. How do you, what principle are you using to move that decimal point? You're saying this one should become 68.3, right? Yeah. 68.3, so the left side went bigger, so the right side's going to go smaller. 1 decimal place bigger, 1 power of 10 smaller on the right. That makes it a multiple of 3. 68.3 is right. 68.3 times 10 to the 6. Good. One more. Let's write the number 27.23 times 10 to the negative 11th in engineering notation. Well, is that power of 10 going to be negative 12 or negative 9? Those are your 2 real choices. Okay, let's make the power of 10 negative 12. That means that the right side's getting smaller, which means the left side's going to have to get bigger. 272.3. 272.3 times 10 to the negative 12th power, and that one's in engineering notation. Okay, well, we're going to go the other direction and then move on. If we've got 247.3 times 10 to the negative 6, we want to write that in scientific notation. We're starting out in engineering, and we want to go to scientific. Well, now we have no concern for what the power of 10 is anymore. Now we just need to make sure the coefficient is between 1 and 10. So here we need to make the left side work. Before we needed to make the exponent correct. Now we just need to make the left side between 1 and 10. That's going to have to be 2.473. Times 10 to the, well, what happened to the left side? Smaller by 2 spots, which means the right side's going to have to get larger by 2 spots. So it's negative 4th power. 2.473 times 10 to the negative 4th. It's in scientific notation. Okay, so we can flip back and forth between the 2 with very little trouble. Questions so far? Does that look okay? All right. Well, operations. We have very little to say about this. We're just going to do one example. The thing to note is that operations are performed on numbers in engineering notation the same way that we would as if they were in scientific notation. You just have to follow the same rules. We have to respect the same multiple of 3's in the powers. And if you're doing computation with numbers that are in engineering notation, you should probably report your answer in engineering notation. Because odds are, if you're doing work in engineering notation, you're working with the metric system, and you want to have a result that's in the metric system. And that's the next transition we're going to make here. We're just going to do one example of a computation in the engineering notation system, and then we'll move on. Well, we're adding numbers in engineering notation. What has to be true here before we can really get rolling? They what? Yep, the exponents have to match. The powers of 10 have to be the same. They're not. So we're again faced with a decision. We can make the 10 to the negative 6 into 10 to the negative 9, or we can make the 10 to the negative 9 into 10 to the negative 6. Do you remember the way that works best from yesterday? Choose the larger one. So let's make this one different. We'll leave this the same. 45.202 times 10 to the negative 6th. To that we're going to add. Okay, this is going to climb up to 10 to the negative 6th power now. Seems like it, but it's not. 10 to the negative 6 is bigger than, I'd rather be $6 in debt than $9 in debt. It's backwards. Easy place to make a mistake. All right, so as long as this side climbs up 3 decimal places larger, this side's going to have to drop 3 decimal places smaller. So 6.3 becomes 0.0063. Everybody agree with that? Kurt? That's a good question. It's not in engineering. But look at the decision you're faced with. Right now, the 6.3 times 10 to the negative 9th, that is in engineering. If we're going to switch it anywhere, we're going to have to leave engineering notation. We'll just have to make sure that our answer is put back in engineering notation. That's a great point. Now we can go ahead and add these two together. The powers of 10 match. 45.202 plus 0.0063. Again, we're going to assume that these are exact values. Technically, we'd be limited to 3 decimals, but in sticking with your text and what's practical here, we'll add those. Let's see, that's 45.203. 2083. And we keep the power of negative 6. Now ask yourself, is that an engineering notation? Yeah, it is, so we're done. Great. Metric notation. Engineering notation facilitates the use of metric prefixes. Prefixes. And the reason that is because powers of 10 that are used in engineering notation always correspond with a word or a metric prefix. That's why we force them to be integer multiples of 3, because those are the ones that have names, plus a few other odd ones. And the reverse is also true. Every metric prefix, and I know everybody here has a favorite metric prefix, one that you kind of like a little bit more than the others. For me, it's giga. I've always thought giga is where it's at. Also, micro is pretty neat because it's kind of got a different symbol, but you've all got your own biases. Anybody want to share your favorite metric prefix? Kyle? Huh? Pico. Nice choice. Kurt? Kilo. Interesting choice. What is it? Mega. Well, if you don't have one yet, you will. On that supplement, that packet I gave you yesterday, on page, I gave mine away. They're all listed, at least all the reasonably sized ones. There's more even than what are listed. Anybody have what page that's on? Page 9 of the current CTM1A supplement lists all the metric prefixes. Now, I have good news and bad news. No, it's just bad news. You have to memorize, not all of them, but you do have to memorize what the value of all the prefixes are from 10 to the negative 12th up to 10 to the 12th. Those are the ones that you need to know, because those are the ones that show up the most often. So you need to know all of them between 10 to the negative 12th and 10 to the 12th, because those are the ones that really are the most commonly used. Also, you should know centa, which most people do. Centa is one of the first ones you learn, and that's 10 to the negative 2. That one really shows up for centimeter, and that's the only place that centa ever really makes an appearance. You never hear of a, well, maybe a centigram, but you never hear of a centavolt. You never hear of a centinewton. It's just not practical. I've listed the ones that you need to know up here. Don't copy that down. It's kind of small to read. These are all listed in your packet. Just in your packet, in your supplement, highlight, mark, somehow note 10 to the negative 12th up to 10 to the 12th, because those are the ones that I won't quiz you or test you on anything outside of these. And if I do, I'll tell you what it is. Now, kilo kind of wrecks it, because in general, the abbreviations for these prefixes are all capitals when you're talking about positive powers of 10, and lowercase when you're talking about negative powers of 10. The exception is kilo. Kilo is a lowercase k. If kilo were a large k, then it would be consistent. Unfortunately, it's not. Also notice that the symbol for micro, since M is already used for milli, micro is the symbol mu. All right. Well, with that in mind, we want to write the value 49.83 times 10 to the third volts using metric notation. We'll start out with some short problems here. Well, this one's really slick, because once you've got a number in engineering notation, all it is a matter of swapping out your power of 10 and putting in the prefix. It's kind of like, the analogy I use is the word dozen. It's a word that carries a numeric association. If I tell you that you have to bring in a dozen donuts to class tomorrow, you know that that means 12, even though I didn't say 12. Well, that's basically the same role that the metric prefixes play. So we go to 10 to the third, and what prefix means 10 to the third? Kilo. And so we would just simply say that this is 49.83 kilovolts. Or frequently use the abbreviation, that would be K, and the abbreviation for volts is V. So 49.83, 49.83 kilovolts. Either one of those two would be just fine. What about 0.0000481 meters in metric notation? Well, the first thing we have to do here is well, it doesn't have to be the first step, but it will be for our purposes because I think it is the most clear. The first form we have to change this to is engineering. Then we'll make the switch with the prefix. So if we put this in engineering notation, we move it 1, 2, 3, 4, 5, 6 places. This becomes 48.1 times 10 to the negative 6th meters. And now we'll swap out that power of 10 for a name, and micro. And so this would be 48.1 micrometers, or 48.1 mu m micrometers. Okay, do a couple more where we've got some scientific engineering notations mixed in. Now, there's a term that you're going to stumble across periodically, and that is the best metric prefix, or the most appropriate metric prefix. And that is the prefix that allows you to express your number, or the coefficient, staying between 1 and 1,000, just like engineering notation. I mean, you can write any value in any number of different metric prefixes. I could tell you the distance from this table to the back door in centimeters, meters, kilometers, or megameters. It's just that the coefficient, the number of those units I have, would change. The best metric prefix is the one that puts your units, or your coefficient, the numeric part, between 1 and 1,000. So for example, let's write the value of 0.019 times 10 to the 4th meters. Now incidentally, just kind of an intuitive question, is 0.019 times 10 to the 4th meters a very long distance, or is that a pretty short distance? Yeah, if you just move the decimal place according to what number is given there, that's actually how many meters? 190, right? 4 places to the right, move that decimal. That would be 190 meters. That's a fairly long distance. Okay? Well, back to the question, though. We want to write this using the most appropriate metric prefix. Well, the step to determining the most appropriate, you don't need to use judgment. It's not about your opinion. It's the beauty of math. We have no interest in people's opinions. There's always one right answer. And that is to put it in engineering notation. Once it's in engineering notation, you have the best metric prefix. So, we put this in engineering notation. What's this power of 10 going to become? It's got to become 0, right? I was expecting somebody to say 3. The problem with making it 3 is, where would that move your decimal? It wouldn't make that coefficient large enough still. If we make this one spot smaller and bring it to 10 to the third, this goes up to 0.19, but that's still too small. So we have to move it all the way to 0. And this will get moved 1, 2, 3, 4. That's 190. There it is. Now we're between 1 and 1,000, 10 to the 0 meters. So what is your most appropriate metric prefix? No prefix at all, just the base unit of meters. That is the one that's most appropriate. So we could eliminate that and say that this is 190 meters. Let's write the value of 500 nanoseconds in decimal notation. 500 nanoseconds in decimal notation. The abbreviation there would be NS, N for nano, S for seconds. Okay, 500 nanoseconds. Now we're going to reverse this. We're going to take out the metric prefix and swap in the correct power of 10. That'll put it in engineering notation. So this becomes 500 times 10 to the negative 9. Nano is an easy one to remember because nano is like -9, negative 9. Nano, negative 9. What show was that where the guy used to say nanu, nanu? Mork for Mork. That's what it was. Yeah, Mork for Mork. 500 times 10 to the negative 9. We want this in decimal notation. So now once we've got this, now we can just move the decimal point. So we're going to have it right here and move it to the left, make it a small number, 9 places. And so we move that 9 places to the left. We're going to have 6 zeros out in front. 1, 2, 3. Group them in 3s to make it easier to read. That's a 9 decimal point move to the left. 0.000000500 seconds. A common error when you're doing these conversions is to accidentally leave the prefix on there after you switch it. Call it 0.000000500 nanoseconds. But nano has already been eliminated when you move the decimal. Okay, a couple more and we're going to call it a day here. We're going to write the value of 87.3 microfarads in scientific notation. Well, let's pull out the micro and put in the appropriate power of 10. Micro is 10 to the negative 6th farads, and it's almost there. The only thing we have left to do is adjust the coefficient. Right now it's too large. We have to make it 8 point, well, scientific, right? Yep, scientific, 8.73. That makes our power of 10 now negative 5. Our coefficient got 1 decimal place smaller, therefore our power of 10 has to get 1 spot larger. And there it is, scientific notation. 8.73 times 10 to the negative 5th farads. Questions about that one, or does it look good? Okay? All right. Last one of this type. Let's write the value of 2.50 times 10 to the second gigabytes in scientific notation. Well, let's swap out the giga. That becomes 2.50 times 10 squared times, now what's giga? 10 to the 9th? Now, we've got 2 powers of 10 sitting here. We've got a 10 to the second that was there originally. Incidentally, why not take this 10 to the second and use it to move the 2.5 over? Why wouldn't you want to do that? You could. Mathematically, it'd be true, but for the sake of answering the question, that's not very efficient. What form do we want this in? Scientific. So we want our coefficient to be between 1 and 10, so why not just leave that 2.5 just the way it is? So 2.5 times 10 squared, which was there, times 10 to the 9th, which is what the giga was, that leaves us with 2.50. And how do you handle those powers of 10? It becomes 10 to the 11th. You add them. 10 to the 11th bytes. We're done. But we will. Okay, the last thing then we need to do, and you'll have everything you need, is switching between metric units. Numbers that are written in metric notation, you can switch from one prefix to another just by moving the decimal point in the coefficient. And the beauty of this is why you don't have to like the metric system, but you do have to like the fact that if you know all the metric prefixes, you don't need to know any other conversion factors in the metric system. I'm a big fan of the imperial system. I like feet, I like cups, and I like quarts. But there's a lot of conversion factors to know. I mean, you got to know how many feet in a mile. You got to know how many feet in a yard. You got to know how many cups in a quart. You need to know how many tablespoons in a cup. You need to know all these crazy conversion factors. And if you're working in the metric system, you don't need any of that. All you need to know is these metric prefixes. So let's do just a couple of those. Now, there are several ways to approach these conversion problems, and you might do it differently. I will tell you that any method that you use that works is fine. You can use any method you choose. You might not choose the way that I show you. And if the way I show you doesn't make sense, stop by and get help, and we'll find a different way, because there's several approaches here. We want to change 0.830 gigabytes, and we want to turn that into megabytes. Now, there's short tricks for just moving the decimal places, and you can do that. But to be consistent with kind of what we've been doing, I'm going to show you this method. We're at gigabytes. What do we want to end up with? We want to end up with megabytes. So the first thing we need to do is say, well, what is giga really representing? That's really the same as 0.830 times 10 to the 9th bytes. Now, we want to end up at mega, which is what power of 10? We want to end up with 10 to the 6th bytes. So we want to get from 10 to the 9th to 10 to the 6th, which means this power of 10 is going down 3, which means our coefficient has to go larger 3. So we're going to go 3 spaces to the right and call this 830 times 10 to the 6th bytes, which is the same as 830 megabytes. Now, if you use a different method, you might use the rule that says, hey, we're going to a smaller unit. We're moving 3 powers of 10, so since we're going to a smaller unit, we'll have more of them, and you'll just move your number and make it larger. Perfectly acceptable, no problem. Any method is fine. Look okay? Let's convert 12,000 centimeters to kilometers. Starting out with centa, that means what we have is 12,000 times 10 to the negative 2, that's centa. What we want is kilo, so we want to end up at 10 to the 3rd. So our power of 10 is getting 5 places larger, which means our decimal point, our coefficient, has to go 5 places smaller. 1, 2, 3, 4, 5, and we end up with 0.12 times 10 to the third meters, or in other words, 0.12 kilometers. And we're done. We moved 5 powers of 10 and we went to a larger unit, therefore we're going to have fewer of them. Number gets smaller when you go to a larger unit, gets larger when you go to a smaller unit. One involving kind of mixed scientific and metric notation. So what this really means is that we have 3.7 times 10 to the 8th milli is 10 to the negative third. Combining those two, we see what this is really equivalent to 3.7 times 10 to the 5th amps. Okay? So we've gotten rid of the milli and combined our powers of 10. Now we need to get it so that our power of 10 is mega, which is 6. So this has to get turned into 10 to the 6th amps. So we just need to bump the right side up one, drop the left side down one, and this becomes 0.37 times 10 to the 6th amps, or in other words, 0.37 mega amps. And we're done. We went to a larger unit by 6 powers of 10, which means we're going to go to a smaller coefficient. Excuse me, I said that wrong. How many powers of 10 are we moving there from milli to mega? That's what I said. I thought I incorrectly said 6 too. It's 9. Milli is 10 to the negative 3. Mega is 10 to the positive 6. You're moving 9 spots. So our coefficient gets smaller by 9 places. And the last one of the day here. Let's do one more and call it good. Let's convert 420 times 10 to the negative 5th microfarads to picofarads. Well, you guide us through this. What do we need to do first? Dave, what do you do first? Yep, so this becomes 420 times 10 to the negative 5th times 10 to the negative 6th farads. Good? Okay. Lump the powers of 10 together, 420 times 10 to the negative 11th. We want to end up with pico, which is 10 to the negative 12th. So we're going to make that power of 10 one spot smaller. This has to become slightly larger. 4,200 times 10 to the negative 12th, or in other words, 4,200 picofarads. And we're done.